Hi viewers, my name is Rajkumar from RK Academy. Today we are going to see the topic complex number. It's from higher secondary second year. Already we completed up to 2.2 exercise. Today we are going to see some basic properties of the complex number. So what about the basic concept of the complex number? Now listen. Under addition, there are 5 properties under addition. So what are all the properties we are going to see that? Now listen, under addition, very first property, closure axiom. Closure property. So what is meant by closure property? Now I am taking two complex number z1, z2. Any two complex number. Sum of the two complex number is again a complex number. Sum of the two complex number is again a complex number. Now for example, z1 is equal to 3 plus 2i, z2 is equal to 5 plus 4i. Sum of these two complex number, so 8 plus 6i. We are adding the real part and the imaginary part separately. So that's why sum of two complex number is again the sum of two again a complex number. Okay. Second one it's commutative. What is meant by commutative? I think we know about the commutative in lower class itself. So what is that? So z1, z2 be the two complex number. Listen. We can write z1 plus z2 is equal to z2 plus z1. From this example, the same thing as, so we are adding these two complex number z1 plus z2, it will be 8 plus 6i. Now again, z2 plus z1, what will happen? The same thing, it will be 8 plus 6i. 8 plus 6i. So it satisfies the commutative property. Okay. Now let us see associative. So what is meant by associative? It's under addition. The process is under addition. So we can write z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. I think you know about the associative property. It's like that. z1 plus z2. So we are adding first two complex number. Again we are going to add the third one. It's equal to adding z2 and z3. Again you are adding z1. So both are same. So that is called associative property. Now listen, the next one. Identity. So what is meant by identity? So additive identity. So it's from the addition. In the lower class, we know that I think it's very low, very 8th or 9th, I think so. Addition identity, multiplication identity. There are both things. What is that? Addition identity, what are that? Listen, the addition identity, what about that? So now I am taking some number, adding the number by any number is equal to 5. Again it will be repeated as 5. So in the identity under addition from the complex number, so what is the possible things? Now I am taking some complex number. z1 is equal to z1 plus dash is equal to, I need the same z1. So what will happen? Okay. Now listen. Now I am taking a complex number 3 plus 4i plus dash is equal to, I need 3 plus 4i. What you need to put here? Now listen. We are adding 0 plus 0i. It will be never changes because addition identity is 0. In the lower class itself we know about that. Okay. Here there is one more condition. Dash plus the same complex number is again a complex number. So in that identity we are need to prove 3 plus 4i plus something, we don't know that, we are is equal to 3 plus 4i. Something plus 3 plus 4i is equal to 3 plus 4i. So what about that something? That is identity. What about that identity? Identity is 0. We can write the 0 as 0 plus 0i. So it's the additive identity. Additive identity of this complex number is 0 under addition. Now listen. Inverse. What about the inverse? Inverse. Now I am taking a complex number z1 plus dash. We need the identity. What is the identity? 0. So dash plus z1 is equal to 0. So what you need to put there? Listen, z1 plus dash. Now listen, I already know about that. Z1 plus dash. Now I am taking a complex number 3 plus 4i plus dash is equal to, I need 0. You know, all of you know about that. Negative of a complex number. Suppose it's z minus z is the negative of a complex number. Z is equal to a plus ib is a complex number. Minus a minus ib is the negative of that complex number. Okay. Now listen. What about the negative of the complex number? It will be 0. So minus 3 minus 4i. Again plus dash plus 3 plus 4i is equal to 0. When it will be happen? Minus 3 minus 3 minus 4i. So what about that? Z1 is a complex number. Minus Z1 is the negative of that complex number. Okay. Minus Z1. Now what about the inverse? Inverse is, if Z1 is a complex number means, what about the inverse? Minus Z1 is the inverse of that complex number from under addition. Under addition. Now we completed the 5 properties under addition. So what about the multiplication? Under multiplication, what will happen? Now listen. Under multiplication. Okay. First one, closer. What will happen in the closer? In the closer, now I am taking a complex number. I am taking 2 complex number z1, z2. Yes. Product of this complex number is again a complex number. Product of the complex number is again a complex number. I am taking 2 complex number from the complex number system. Now z1, z2, product of this one is also a complex number. Just you want to know that, just you multiply the complex number. I already just multiplied the 2 complex number. Okay. Second one, commutative. In the same manner, we are taking 2 complex number. Z1 into Z2 is equal to Z2 into Z1. So both are same. In that addition also, commutative is true. Under multiplication, it's also be true. So the next one, associative. So product. Here we are taking the product. So what will happen? Z1 into Z2 of Z3 is equal to Z1 of Z2 Z3. So it will be satisfied. If you want to know about that, just you take some 3 complex number and multiply that. Okay, identity is very important thing in the multiplication. The identity is very important in the multiplication. Then there exists an z. Now I am taking a z complex number into dash. I need again z. I need again z. How to find that? Sir, I don't know what the number I need to put there. Okay. Sir, is it 1 plus 1i or 1 plus 0i? So what about that? Addition means I know that 0. So we are writing the 0 as 1 plus 0i. Multiplication is 1. Sir, how to write that 1? 1 is 1 plus 0i, we know that. But there is a doubt in that. Okay, now we are going to find the identity. How to find the identity? The identity, listen, z into, what about the z? Shall we take 3 plus 4i into dash is equal to 3 plus 4i. So how to find the identity here? Now I am taking the identity as x plus iy. We are going to find the x plus iy means, so that is the identity. Yes, 3 plus 4i into x plus iy is equal to 3 plus 4i. Okay? Yes. Just multiply. 3x plus 3yi plus 4xi. So here 4yi square. What will happen? 4yi square. I square is minus 1. So minus 4y is equal to 3 plus 4i. So 3x plus 4y. Take the real parts equal to real. Again, imaginary part I into 4x plus 3y. 4x plus 3y is equal to 4. We are solving these two equations. We may get, what about the x? X is equal to 1. We are solving these two equations. We will get x is equal to 1 and y equal to 0. It's very simple. We are solving these two equations. So what about the x and y? X is 1, y is equal to 0. So what you need to put here? 1 plus 0i. 1 plus 0i. Again there is a concept. Z into dash is equal to z. Dash into z equal to z. So what you need to put here? 1 plus 0i. What is 1 plus 0i? That is 1. 1 is a complex number. How to write that 1 plus 0i? It's the next one. It's very important thing. Under multiplication, how to find the inverse? Listen. Inverse. What is inverse? Now we are taking some complex number z into dash is equal to identity. What is identity? 1. So now we are going to take some examples. Now listen. Z into, I don't know that. What is z? Shall I take x plus iy? Yes, x plus iy. Then how to find the dash? What about that? We have put some complex number, it will appear as 1. It's the inverse of this one. It's the inverse of this one under multiplication. So how to find that? Now I am taking some complex number, some example. Okay, it's very easy thing I think. Z is equal to, shall I take 3 plus 4i? Anything else? So what about the dash? Now I am taking some values as it's z1. I don't know that. X plus iy. We need the answer. The product of these two equal to 1. So okay, how to find? Z x plus iy into 3 plus 4i into x plus iy is equal to 1. Just multiply. 3x plus 3yi plus 4xi minus 4y equal to 1. Okay, the same thing. It's in the product. We are getting 1. That's all. Okay. Now 3x plus 4y, minus 4y. Here there is minus. 3x minus 4y is equal to 1. 4x minus, plus 3y. So take I as common is equal to 0 because there is the imaginary part is 0. Now we are solving these two and find the inverse of z. How to solve? Okay, you may solve that. Listen. So we are solving these two. Just the first equation. I think there is a problem in exercise. We can use directly the formula. Okay. What about the formula? We are going to see that. Very first, just I multiply by 3 and 4 here. The first equation has 3 and second equation has 4. Okay, first equation has 3. What will happen? 9x minus 12y equal to 3. Again, it's second as 3. I mean 4. Second equation into 4. What will happen? So 16x plus 12y equal to 0. So now it will be balanced. 25x equal to 3. X is equal to 3 by 25. X is equal to 3 by 25. Yes. Okay. Now I am multiplying the first equation as 4. Second equation as 3. What will be happen? First equation as 4. So it's 12x minus 16y equal to 4. Again, this one multiplied by 3. 12x plus 12y. Multiply by 3. 9y is equal to 0. What will happen? Change the sign. Minus 25y is equal to 4. Y is equal to minus 4 by 25. Okay, sir. If z is equal to 3 plus 4i is a complex number, the inverse of the complex number is z1 is equal to, what about the x? We already found the x, 3 by 25 minus I into 4 by 25. So what is the inverse? Suppose it's a complex number, the inverse of the complex number is that 1. So it's a formula. Suppose now I am taking a complex number. Listen carefully, it's very important. Now I am taking a complex number. Z is equal to x plus iy. How to find the inverse of that? We can find inverse. Z inverse is equal to x by x square plus y square minus I into y by x square plus y square. We may take this one as a formula. It's in the exercise problem. So we can directly implement the formula in the third exercise, I think so. So now listen, we are taking a complex number. So what about the inverse? We can write like this: real part by sum of real and imaginary part square minus imaginary part by sum of real and imaginary part square. Sum of the squares of the real and imaginary parts. So it is the formula. Suppose now I am taking 2 plus 3i. What is the inverse of 2 plus 3i? You can directly write that real part by sum of the squares of the real and imaginary. 2 square plus 3 square. 9 plus 4 is 13. Minus, you put the minus, I into imaginary part by 13. Suppose it's minus here, we can write here as plus. Okay. Now we completed the properties. One more property is that it's very simple. So what mean by that? Listen, distributive. We have distributive there. Z1 into Z2 plus Z3. We can write Z1 Z2 plus Z1 Z3. Already we know the distributive in the lower class itself. It will be satisfying the complex number itself also. Okay. Now it's the distributive property. Okay. Now we completed the properties. We enter to the problem in the next class. Thank you.